Yeah, you guys want to do the template first or the general note first?
Template.
Tell me about the template first.
3 of these.
One of these. Template wins.
So right thing. You're in dangerous waters.
Actually, he's smart.
Yeah, I guess that.
Where you going, Nick?
I'll be quick.
He's gonna go.
Yo, little boys in the room's calling my name.
Did you say the little boys are calling? Nature's calling.
So we're doing chi-squared. This is the last major topic we have. Good, because we have like a week left. There are 3 different types of chi-square tests. If you read through the packet, it's all in there. So there's kind of like notes for everything we're going to be doing the next few weeks, next few days in there. I'm going to go through it with you also, but just that packet can be a nice resource for you. So that X thing is the chi. That's like the Greek letter chi. Chi-squared, and there's 3 types. There's goodness of fit, there's homogeneity, and there's independence. Goodness of fit is the easiest one. That's what we're starting with. We'll get like the main idea behind that down. Then we got 2 more. Then there'll be 1 more test. So there'll be a test on like this unit. I'm leaving. My last day is the 7th. So of May. So we only have 8 classes left when I'm here.
Where are you going?
I'm getting surgery on my other hip this time.
Are you going to be out for the rest of the year?
I'm out for like a month, so
Almost.
mostly you'll be gone, yeah.
No,
I'm trying to go to my class tonight if I can.
I don't get to leave early.
Right.
No, you should come. Like, my boyfriend Lynch might be there.
Mr. Davis, did you have little beds, like the nurse beds? Just lay there. Figure out.
A bed? I have a bed.
No, like a little person bed, like for patients. And like they recline and stuff for like studies in the hospitals.
I have that at my house too. Are you calling me old?
Are you serious?
Yeah.
My dad has one of those chairs that like goes on story time. Yeah. Go ahead.
Seriously. Alright. So biggest thing, I'm going to do the conditions first. The biggest thing is chi-squared is always categorical. So everything we've done so far has been numerical, or like quantitative if you want to call it that way. But like a proportion is a number, a mean is a number. Categorical is like slots or categories. So M&Ms are either going to be green or white or red. And it's not something you could really like take the average of. Like, what's the average of green and red? That doesn't make any sense. But you're fitting into like these bins, and it's not possible to be in the middle of those bins. You have to go in one or not in one. Like AP scores is another one. I know it's numbers, but can you get like a 1.2 on the AP test? You can't. So you either get a 1, a 2, a 3, or 4, or 5. You have to be in these bins or in these categories. You're either a freshman, a sophomore, a junior, or a senior. You can't be like a freshman 0.5.
Because we're seniors.
Probably are some super seniors, so like, yeah, senior 2.0 or something. I don't know, but yeah, you get what I'm saying, right? Shh. All right, assume SRS or stated. And then the third thing is each expected cell needs to be greater than or equal to 5, and you're going to put C below, and then we're going to take care of that down below. So that's the getting into the process. The biggest thing I wanted to start with is these are categories. Category chi-squared, unfortunately, we'll start with the same letter. So that's what kind of makes it easier to remember. So you got T's, which is means, Z's, which is proportions, and then chi-squared, which is category. All right, so the first thing you would do is you would say H naught would be all population proportions of context are as expected. be at least one population proportion is different than expected. So the general idea is like, so the AP test claims, and they say this, that 20% of people get ones, 20% get twos, 20% for every score. From what I've seen, I don't really believe that, but I also don't see all the data, you know, so I just made up the numbers. Let's say these are the observed. This is not the observed for this class. Like, it would be, we do better than the average usually. But let's just say this is the observed. If I took 200 people, and I expect 20% of them to get a 1. How many people then am I expecting to get a 1? Say 6. 20% of 200.
Oh.
So if there's 200 people that took it, and I saw, this is my data, I saw 30 people get a 1, 50 people get a 2, 60 people get a 3, etc. If 20% are supposed to get a 1, and 200 people took it, how many are supposed to? How many people are supposed to get a 1? 40, and how are you getting that? 20% of 200, right? So we'd expect all of these to be 40s. And then I see, well, they're not all 40s, but they're not far away either. Like, is this far enough away that you're like, the AP test is lying? Or is it kind of in that gray area, or is it, no, I think it's okay. That's the game we're playing here, right? So we're just trying to figure out, are these farther away than what we expect, or are they okay? Does that make some sense? Okay. It's basically like a 5, this would be like a 5 proportion z-test. You got 5 categories, you're trying to see if the proportions fit. It's not exactly it's categories, but okay. So then for the math box, you're going to write down the chi-squared formula, which is, you guys seen that little E before?
Yeah, some.
That means, that's a sigma, that means the sum of, so you're adding up all this stuff. Observed minus expected squared, that's why it's called chi-squared, divided by expected. So like these would all be 40s, right? If I wanted to know the chi-squared statistic for this individual point, I would do 30 minus 40, square it, and divide by 40. And then what's happening is the calculator's going to do it. We'll do that for all 5 of these, but add it up. Okay. You're also going to make a little table where you're going to go observed, expected, and then chi-squared. And then depending on how many categories, you're going to list the observed, the expected, and the chi-squared for like all of it. In this case, there's 5. It could be 3, it could be 4, you know, it could be whatever, but you're going to have to figure those things out for every category. You get a chi-squared here, then you're going to go chi-squared CDF. So there's a normal CDF for Z's, there's a T-CDF, there's a chi-squared CDF. You're going to take the chi-squared value and go up to 999, and it's always up. You'll never go down in this one. Common degrees of freedom. The degrees of freedom is n minus 1. I'm sorry. Categories minus 1. So, like, what would the degrees of freedom be in this one? 4, right? So the number of, like, slots you have minus 1. What's up? You got it. And that's going to give you equals, kind of around the room. But what does like TCDF tell you? What does normal CDF tell you?
Probability of getting that and more extreme values.
What's the word for that? CDF, like, 2.2, comma 999, comma whatever, what does it give you? It gives you a p-value. So that is giving you a p-value. And you'll have an alpha. And then you're going to make your decision at the end. So your decision could go both ways, right? So since p is less than alpha, what would we do with H naught, if that's the case? Since p is less than alpha, we reject H naught. There is enough evidence to, we're just going to do this, we're going to shortcut a little bit, to support HA. Or, the opposite, since p-value is greater than alpha, we fail to reject HO, which means there is not enough evidence to support HO. I mean, technically, you've already defined what HA is, so no. I like when you do that because it like reinforces things for you. But at this point, kind of in the interest of time,
So
it's not wrong to put that.
On an AP test, we just put like
You'd be okay.
So
I was making you do more to like make you practice more, but we don't have time for me to make you do more anymore. Questions on this anyway? I mean, I know you don't know what you're doing yet, but
I see what's on
on the template, are there anything I can help with?
I do have a question.
So technically, you already did, because if you go to the top, what's HA? Like, we already put context KHA, so you're allowed to say what I said in this case. Like I was telling him, I didn't make you do it before because I think it's good for you to practice the context, but at this point, like, we only have a week left, basically, so.
So how do you do that?
You can write what I wrote here, maybe.
Okay.
Yes.
All of them?
Yes. Yeah.
So that's the
The what?
third schedule.
Yeah.
Like,
Yeah, but I can't really explain it until we do one. So it won't make any sense till we do it. But basically what it's saying is the expected cells are here. So when we figure those out, those all have to be 5 or more. You ought to figure them out. I mean, I'll get to it. Yeah. Got to do math first. Anybody else need this? Top, bottom, anything? Alright, so we're going to do this one. So the first thing you're looking at is how many samples did you take in this problem? 1. There's 5 different things that came out of it, right? But there's only 1 sample. And how many variables are we looking at? Don't say 5. 1. What's the variable? The score in the AP test, right? And there's like 5 different scores, but that's the only variable. So 1 sample, 1 variable is goodness of fit every single time. So that's why I wrote this up here. 1 sample, 1 variable is goodness of fit. So I'm going to go chi-squared. You can just write GOF. I'm going to write 1 sample, 1 variable. You don't have to, but I recommend that you do because it gets kind of difficult to figure out which of the 3 chi-squared types is which. And if you can remember this, that will help you remember which is which. What?
Yeah.
Sorry to interrupt. Alright, HO. All population proportions of AP scores are as expected. HA. Like really, so I'm writing like I was gonna write at least 1 proportion is different, but you could just go, all population proportions of AP scores are not as expected. Yep. I actually don't know that. I would. Because so whenever you have something like that where I'm kind of in doubt, just put it, you know. First condition is categorical. Is this categorical?
Yes.
Yes. Because could you get like a 2.9 on the AP test? You can't. You can only get a 1, a 2, a 3, a 4, or a 5. That's it. There's nothing in the middle. There's no other numbers. So it is categorical. And I'll be honest with you, the AP test doesn't require that. I am. So on my test next week, you're going to have to put that. On the AP test, you actually don't. But it's going to help you remember stuff. Assume SRS. I don't really say anything about it, so we'll have to assume that. And then each expected cell greater than or equal to 5. Put C below, because that's where we're going to actually prove it. We're not actually proving it yet. We're just going to say, like, hey, I'll get to this in a second. Write down your formula, and this formula is on your formula sheet, so you don't have to remember it. I'm going to leave a blank there because I'm going to put the answer there when I eventually get it. I'm going to make my little table here. Always have to have observed, expected, and chi-squared. And then the columns, like the part across the top, depends on the questions. 1 through 5, we're going to have 1, 2, 3, 4, 5. If it was like grade in high school, I put freshman, sophomore, junior, senior. Favorite subject, I put English, math, science, or whatever it is. So the observed, I can just write in. I'm just writing in the data that I see. This is what I observed. This is what actually happened in my sample. And then I would total those up. I think that's the easiest thing to do. So there's 200. And then pause. You alright, Squid?
Yeah, I doesn't give up the 3 is passing.
If the what? The 3 is passing yet. Don't think that's my actual data, though. My data's better than that. I don't want you to think I'm a terrible teacher. Although, you probably already formed your opinion on my teaching, I suppose. Yeah, good or bad, you probably have.
Integrated math stuff, that's all. Integrated math was good.
Still wish I'd been here when you guys fought. Anyway, so the expected is the part where you actually start doing some math. So what percent of people would I expect to get 1? 20%. How many people are there? 200. So when I'm going to multiply the 20% times the 200, and that's going to give me 40. I just want you to make sure you know like where that number's coming from. Yeah, what percent would I expect to get at 2? It's 20%. 20% of that total 200 is 40. So these are all 40, right?
Yeah.
Do you see where I'm getting the number from?
Yeah.
Okay.
Are they always going to be the same?
No.
But they'll give us.
They'll give it to you, yeah. Yeah, these won't always be the same, but you will always have enough information to figure out that. On the chi-squared, there's 2 ways you can do it. If you really wanted to, you could go, like, take the 30 and the 40, and those are your observed and expected, right? Plug them into this formula, get a number, put it down here. Do it again with the 2s, plug them into the formula, get a number, put it down here. And do it 5 times. I don't really want to do that. I doubt you want to do that. put your observed in L1, expected in L2. You don't have to write that on the test. I'm just doing it so you can see. Observed L1, expected L2.
What are these days I'm actually looking for parameters?
What are these days you're going to want?
Remember to grab batteries.
Oh.
Maybe someday.
So you're like switching back and forth.
Yeah, between Kelvin and stats.
I have somebody gotta give you $1. Four batteries for $1.
You got them for like
Carry cash. Yeah, but that's what he charged.
No, those they were like $1. That's about what it was when I like went through.
Making a small profit.
I just can't say like I'm gonna give them out because then everyone will take some, so I have to charge them. Yeah, I'll pay it, so I can't get discounts now. We good there?
Yes, sir.
Everybody have the 2 columns in? Said no.
I have batteries.
You just transfer from one calculator to another.
Calculator and stats.
How we doing, Marty? Alright. Stat, tests, chi-squared goodness of fit. So you see there's 2 different chi-squareds. So we'll learn the other one in a couple days. But you want the chi-squared goodness of fit test. So go to that one and hit enter. And that's exactly, like it should default to this. Hopefully you guys just say L1, L2 right there. So that's why we put the observed L1, expected L2, because that's kind of what it was wanting us to do. Degrees of freedom is categories -1. So what's that? 4. Then you enter. So a couple things here. The chi-squared, the overall value of chi-squared is 20. So we can go to our sheet and I'm going to put 20 right there. It also gives us the p-value. So how do I find p? I'm not actually going to find it, but what do I write out to make them think I'm finding p-value? Chi-squared CDF 20, comma 9999, comma 4, and then label that in degrees of freedom. And that is 0.0005. And that's the p-value is 0.0005.
At that point, you just try to mark.
It's going to say 4.99.
Did you get the I didn't really give you an alpha, did I? Let's say alpha equals 0.05.
It says P is not 5.
No, it doesn't. Please look at the end of the number. And then the last thing, so you know what I'm saying? Okay. So the last thing is that the bottom, it actually took me like 2 years to figure out the calculator did this. I thought that was standing for like contraband. Right? Like, doesn't it seem? And I was like, what are these freaking numbers that are talking about? Like, so it's actually contribution, and it's those numbers that you're going to fill in at the bottom of this table. So you got to use the arrows to scroll, but it says 2.5, 2.5, and if you scroll over with your right arrow, you'll get the rest of the numbers. So that allows you to fill them in. Those numbers mean something, and I would like to talk about what they mean. Wait a second. So that's what we could have done, but I'm allowing you to skip. But if I took 30 and put it there, 40 and put it there, 40 and put it there, and worked that all out, what do you think I get? I get 2.5. I did it with that, I get 2.5. I did it with that, I get 10. So that's like the individual contributions. And when you add all those up, what do you think you get? 20. So you're basically adding up like how far away we are from what we'd expect. The bigger this number is, the further on we are away from what we expect, and the more likely we are to reject, right? If we're like really far away from what we thought we would be, a bigger chi-squared is going to give you a smaller p-value, and then you're probably going to reject. What they'll like to do with that information is say something like, which test score contributed the most to the chi-squared statistic? The 3 did. So what does that mean? Like, what does that mean if it contributed the most? It was like the farthest away from what we wanted, right? So this is, according to like what we expected, the 60 is the one that's like the most, which you kind of knew already, but that's just confirming it. Questions yet? I forgot on the template that you make a drawing, but you're going to make a drawing. Chi-squareds are always skewed to the right. That is a phenomenal skew to the right graph.
Were you being facetious there?
No, do you think I was being? Look at that.
No, like
monster. You think I was
I thought you
facetious?
were, and it was like looked really good. And I was like, are you sure?
Oh, that's
So that's all you gotta do with the graph. Basically, I'm making a graph it so that you remember it's skewed to the right. Is kind of my whole point there.
If our thing is not obvious, it's skewed to the right, we get points off.
How not obvious are we talking here?
Like pretty not obvious.
If you make it like if I think it's a normal curve, then yeah, you're gonna get points off. So make sure when you draw this, you draw it skewed to the right.
What if I be super safe and say right skew?
That would help. That'd be okay. So you might want to go back to your template because I forgot to put the drawing on the template.
that's
Yeah,
Just put that
heck of
there.
a hill there.
What?
Mountain. Point.
This is a terrible skewed right graph, but it works. Yeah.
Do you draw it in the last box, or does it matter?
There are no boxes really, you know.
Doesn't matter.
It doesn't matter. On the AP test, you get like a blank sheet of paper. So
Yeah, that's what I figured.
yeah. All right, and then the conclusion. Since p-value, are we less than alpha or greater than? Less than alpha. We
We have to write the parentheses stage back.
we reject H naught. So there, what
Yes.
is what? Enough evidence to support HA. And remember, what is HA? That's different than what we thought it would be, basically. So we're kind of calling the AP test a liar at this point, based on our little data here. So you asked before about the expected cells. Basically, we're checking that all of these are greater than 5. And they will be, like every time you do it, you just kind of like going through the process. And you're like, look, I know what's supposed to do it. Does that answer your question? Any questions on this? Anyways. There's 2 problems in here. I want you to try the one about chickens. Chicken feathers. Did I already give you this?
No, sir.
Yes. Yes. Oh, that's like the note. Oh, wait.
Such a nice person. Get out of my way.
Thanks, I think so too.
Good call.
Thanks.
What you do want chickens. Chicken sandwiches.
Alright, so if you read through this, the chickens have either very curly, slightly curly, or normal feathers. So is that means, proportions, or categories? That's categories, right? You have to be one of those 3. You can't be like between Like they're going to put you in one of those slots. We're not dealing with numbers here. It's just which slot are you. So as soon as you send them, okay. So then again, how many samples did we take? One. How many variables are there? One. And what's the variable? Like feather type, right? So it is a chi-squared GOF. I'm going to write one sample, one variable. You don't have to do that, but I think it's going to help you remember like which is which. Somebody raise your hand and hit me with HO.
All population proportions of feather types is as expected.
All population, yeah. Proportions of feather types. I'm going to say R as expected.
Yeah, I know.
But that's okay.
I said type and then I'm like,
All right. HA. All population. Proportions of feather types are not as expected. Can you give me a category or give me a condition? Oh, shouldn't use that. Okay. Assume SRS?
I thought you basically used it, so I
Yeah, that was good. Appreciate it. It is categorical. Kenny, what's the third one?
Each expected cell is greater than 5 or equal to.
Each expected cell greater than or equal to. Hey, you got a question?
Yeah, so on HA, do you want us to say on, or do you just want us to say one, or does it matter? Because on the template we put one.
So I'm making the same statement two different ways. You can say what I said here, or you can say at least one of the proportions is different than what we expected.
Okay.
Like you see how those are the same thing, kind of just
Yeah.
reworded. Yeah.
You can say C below that.
Oh yeah. See,
That's what I was thinking. I was talking to both raisers. He said, yeah, Nick was about to talk, but he started talking. And then we wrote this in.
we all know what happened. We don't need to like replay the entire scenario.
After action.
And it was boring, so it's not like a highlight video or something. Okay. Kyle, what do you want me to put next?
The formula.
What is the
I
formula?
squared equals the sum of observed minus expected squared over expected.
I like making that E thing.
I got him out of that.
Oh, okay.
You know it as a radiator.
Yeah. Nobody cares that you did it. Caleb, what next? What next?
Sorry. Grab my cup out. You make the box.
Make that table, so I'm going to go observed, expected, and then chi-squared. Mr. Hill, what am I putting across the top here?
Well, you could do very curly, slightly curly.
That's what I'm talking about. So very slightly normal. I mean, I guess it is 1, 2, 3, but you have to like label what the 1, 2, 3 are. You know, just doing content. Yeah.
But you could like, if you make the box, put 1, 2, 3, and then off the sides, one like one equals fairly curly.
Yeah. Yeah. So the observed is what we saw. So that's the numbers that they gave us. So they told us 20 had, I kind of gave it to you in a weird order. So make sure you put them in the right spot. So 20 had normal feathers. 50 had slightly curly. And 23 had very curly. I would total those up. So you got your number here. So I already gave you the total is 93, but just writing it there I think is helpful for like the next step. So the next step you actually have to think. So what percentage of chickens would I expect to be very curly? It's 25%. And I have 93 chickens. So you're going to do 25% of 93. So it's 23.25.
Oh, so you can have an expected as a decimal.
Yeah, you can't have it observed as a decimal, but you're expected. That's like an average, so like an average can be a decimal. What percent would I expect to have slightly? What percent? 50%, so you do 0.5 times, that's 46.5. And then this is the same, this is also 25%, so it's also 23.25.
So that's 20.
Yeah, like that doesn't change the expected though.
Right.
So this, I'm going to run through my calculator and have that tell me what the answer is. So then remember, your observed goes in L1, your expected goes in L2. And you can actually, so this might help if the numbers are more of a pain. You can go here and set it, if I don't know the number yet, I can type in here 0.25 times 93. Like this is what I'm supposed to calculate, right? Like what's 25% of 93, and if I hit enter, it'll put the number in. So you can do your calculations here almost, and then just write it down if you so desire. Now what? Test chi-squared GOF. Observed L1, expected L2, that's what I want. How many degrees of freedom in this problem? 2. We have 3 different categories of feathers, so you subtract 1. And then if you run it, it tells you the chi-squared in this case is 0.72. I know it tells me the p-value, but I have to pretend it didn't. I go, okay, chi-squared CDF, 0.72, comma 999, comma 2. Label your degrees of freedom. And that equals 0.698, which is my p-value. Did I tell you alpha? Not, so let's just go, okay, let's say alpha is 0.05. What am I missing here? Gotta fill in the contribution part. So the first number is like 0.0027. If I keep scrolling, then we're at like 0.263. Then 0.454. I want you to notice something here. If I just went straight up numbers, like forget this calculation or anything, forget this even exists, aren't those two farther apart than those two? Those are actually 3.5 apart, and those are 3.25 apart. Why is that a bigger chi-squared then? The reason is it has to do more with percents. This calculation is getting more at a percent than actual numbers. So this is 3.5 away, but 3.25 is a higher percent of 20 than 3.5 is of 50. If that makes any sense. If it doesn't make sense, it's not the end of the world. You can still do it. I'm just trying to get out in front of some questions. Graph this. Skewed right. That chi-squared's like way over here. It doesn't really matter where you put it, but that's a huge chi-squared. The p-value is 0.698. What's the biggest the p-value could ever be? 1. So you got more than half of that graph. Questions yet? Anywhere? Not sure where you're getting this. What's this about? What's happening here? So all that's left is your conclusion. So since p-value is greater than alpha, 0.698 is greater than 0.05. We what? We what? Yeah, okay. I didn't hear you say failed to. Freaked me out. What? Fail to reject HO. 2 supports HA. So they'll make multiple choice questions out of a lot of this too. Like they could just give you this initial problem, like just give you this paragraph and then say, what's the expected value for slightly curly? You would just throw in your calculator and you just look for that number. Or they could say, this is the most common one, which category contributes the most to the chi-squared statistic, and what would that be in this case? It'd be normal just because that contribution down there is the biggest. Why is this one like tiny?
It's only 0.2 off.
We're like right where we're supposed to be, basically, right? We're almost right on top of what we should have. Questions on any of this? Steve, okay? So there's one in the back. That's your homework. You got 7 minutes now. You might be able to get a decent way through it. Finish that one in the back for homework. What kind of Band-Aid is it? This is what you're worried about, bro?
I just noticed it. I was just wondering.
I think it's Shopkins.
Nice.
I don't know, though. I don't think I've seen